So this video is going to go through colour and why different colours exist, why we see different colours, and then it's going to go through the process of colorimetry. So this is using colour to determine something. So using colour in a meter. So what does it mean to be coloured? So we're now halfway down the rest of that page. So we finished the absorbing emitting energy. This is the title. It says colour of a substance. It says objects will appear coloured because they absorb some of the wavelengths of visible white light, and the wavelengths they don't absorb, they'll either transmit them or they will reflect them. But in this case, this is where my eye is, over on this side here, and you can see that we're getting the green, blue, violet, yellow, indigo. Those wavelengths are making it through to my eye, but the red and the orange wavelengths are being absorbed. So what you might guess is, what color is this going to appear as? All right, so how might we figure that out? So what we actually do is we see the complement color. If you remember your color wheel from when you did art, we actually, it's a bit different with light, but not too different. Yeah, the colors are still the opposite, and you can see them on your little color wheel there. So depending on what color is absorbed, we see the complement color. So because every different substance will absorb a unique set of wavelengths, both the absorbed wavelengths and the transmitted ones, the ones that make it through, can be used to help identify a particular substance. So this is what we call qualitative analysis. Quantitative analysis can also be performed here because the amount of light is proportional to the concentration of the substance. So if you're just looking for what is the substance, so what is the element that you're looking at, we're calling that a qualitative observation, but you can also look at what is the concentration of the substance that we're looking at, and that is what we call a quantitative observation. So quantitative analysis can also be performed because the amount of light absorbed is proportional to the concentration of the substance within the solution. That is, the higher the concentration, the greater the amount of light absorbed. So how does that look practically? So you can see this here. You know, you've got a bunch of what we call standard solutions. So this is the process of colorimetry. So colorimetry is now taking a bunch of known concentrations and using them to figure out unknown concentrations. So what we have here is colorimetry is a method of quantitative analysis. Now the process involves these guys here. So we get these solutions here, and you can see they're getting darker as we go from left to right. So these are what we call standard solutions. Now these are solutions of known concentration, and we prepare them so that they've got usually nice standard increases. So you can see here that this one's concentration is 0.2, 0.4, 0.6, 0.8, and 1. Now it doesn't tell me what unit that is, so that's not great. We're just going to, for the sake of this, we're going to call it molar. Yeah, so that's a 1 molar solution is right on, it might be a copper sulfate, looking at the color of it, through to a 0.2, and this one here would be a 0 molar concentration, so pure distilled water. So what you do is you put all of these in your, so what you could do is you can line them all up in a nice row like that, and then you get your unknown, so you make up your concentration of solution, and you can just kind of put it alongside them and figure out where your colors match. And therefore you can go, okay, I've got a color that's kind of in the middle here, so I would say that that's about 0.5 molar. Or if it looks exactly like this one here, I would say that that unknown concentration is 0.8. So that's somewhat good using this kind of scale, but it's not completely accurate, and it doesn't help us for those gaps. Yeah, or what if something looked darker? Yeah, if something looked darker again, how are you going to be able to tell that concentration? So what we do instead is we use this meter here. Now this is an older version of what we've got at school, and I'm hoping that when we get back there, we'll be able to play around with one of these colorimeters and I can show you how they work in real life. So the colorimeter is a machine, and it actually measures the amount of visible light that passes through them. So if I imagine here is a light source over here, here is my light source. So this is light. if I pass it through this substance, you might see 4 rays get through the clear solution. You might see only 2 rays get through that solution. So what we do is there's a detector on this side, on the right-hand side, and that detector will actually detect how much light has made it through the substance. Now, the less light, so I'm going to change my color. Here we go. The less light that is transmitted, what do you think that means about the concentration? Yeah, so if you get less light transmitted, we get higher concentration. So this is one way that we can use a bunch of known concentrations to figure out some unknown concentrations. And we're going to do another video on calibration curves and how to use this data to figure out your unknowns.